Hello. In this video I introduced a new rewrite of the patches code, and well, the results are pretty good because I made the system much easier to read and much clearer. And I started off with deleting a bunch of systems and code from my program. And here we see this subdivision object, and it has two modes to it, and this one is with patches on, and when I switch to another mode, then it looks like edges are influencing Catmull-Clark subdivision surface there. And this one looks pretty nice, and I increased also the subdivision levels that are possible by 1, and results are pretty good. And let's take a look what I did in my code. I just very quickly do a brief about this changes. In the old code I had this in the another function that increases the subdivision levels there, tune in subdivision shape transformed underscore, and this one was a very complicated and a long function with very tedious logic there, that very many sentences that maybe were not necessary also in every situation. But here I made a test on this soccer ball geometry, and also unnecessary test is for cube that is transformed into a cylindrical shape. And it's not the perfect, but anyway, the first two subdivision levels come well out, and the rest of it uses also the same code in calculating the subdivision levels, and it looks good. And I have deleted those object structures, those let's take a look what I have changed. I need the glasses here, sorry. My vision is quite bad, and I got no new glasses here, and I see here in a previous version I had in quadrant structure I had something here more of those variables, and I removed those, and also in the polygon structure, and possibly also in edge structure I had something here, and in vertice structure. And one thing that was removed with edge structures was the smoothness calculation. Here was a smooth variable, and I had lots of functions that calculated, basically categorized those edges that were subdivided. And let's take a look at a little drawing here, not to be that abstract with my talking. And here we see a subdivision surface in principle, and we see here that this one is the main gauge. Here there's the big square here, and the edge smoothness was basically categorizing edges putting those inside edges, EIs, into one category, and those edges that lie on the perimeters into another category. Maybe, I'm not 100% sure, but something like this was done. But those smoothness is unnecessary, because we have edges organized in a special way also in those arrays, and we see here how those edges are found in the arrays. First off, the edges are the perimeter edges here. Then in the array are the inside edges. This is the organization for the edges. And here, what is interesting in this code, I just talk it to be as a remembrance and maybe a guide in the later stage. Here we have the subdivision shape transformed underscore function, and we get this little bit odd looking function here for the for those perimeter edges. Basically, for those perimeter edge vertices, we need to calculate those perimeter edge vertice positions, and this goes also for those smaller subdivisions, the same thing. And excuse me, this was not about this perimeter edge vertices, right? But inside edge vertices was this section of code, basically about this C vertice. And I got an idea that for every edge vertice I could use previous subdivision point vectors to calculate it, but I tried it out and this was not the case, and this was not simple. And instead, a much better way is to utilize those the crossing line of it. And this is not so easy to find those A and E vertices on the opposite extremes. Of course, when the subdivision increases, then the same principle applies, but the A and E vertices are maybe inside the patch, and but they have still something like a reasonable effect. And this is a section that we have here. This is the section, and it finishes off. And essentially we can observe those the C vertice we can observe two ways. One way is to observe it from the superior level as an inside edge vertice, but another way is to observe it as a cage vertice for the next subdivision level or the current subdivision level. It is also the cage vertice for this this subdivision level. We can observe it in two ways, and I observe it like a edge vertice for this subdivided cage, but not as the inside as the polyvertice, not as a polyvertice, but as a subdivision vertice for this subdivision cage. And here we get a very obscure and hard to understand syntax here. and we see I get this identifier IDX or index 2 times. I get this in a row. Usually we get an index in one line, and then we query the element for proper level. But here we get 2 times index calculation, and it utilizes the age slots variable. And this age slots variable is a very interesting thing. Let's imagine that we have this, we've observed this age in the previous subdivision level, and we get 2 polygons connected to this inside edge, and this first polygon in a counterclockwise and the second polygon. And this edge slots variable for this edge tells the nth edge for this polygon. Slot 0 means that this edge is found for this polygon at this slot index, and slot 1 relates to this next polygon, and this edge finds maybe another placement in the 4-element array. This is for quads, of course. And here we see this syntax for this quad element calculation. And then we get this indice, and then we use this vertice organization that states here. You see, we look at the vertice organization, and we see cage vertices, edge vertices, and polo vertices are the vertice organization. And we find those edge vertices, of course, and then cage vertices precede, and that means this vertice count for the previous subdivision level. Level 1 means, or L1 means L minus 1. This is the previous subdivision level, and L is the current subdivision level. L1 is closer, and L is the current. And then we find those extreme vertices. They are noted as V0 and V1, and essentially they correspond in this drawing as A and E for this C vertice. And this way those vectors came added up and divided for mean division. This is the central division. And essentially this the same algorithm repeats for the final subdivision levels also. It is not 100% correct, but it yields, so to say, best results that I can get. I'm not going to make it any more complicated here.